Hi, this is Mrs. Vrobel. This is Chapter 13, Gases, Part 2. So in this video, as I mentioned before, we're going to be looking at the relationship between pressure, temperature, and volume with not altering the amount. And the two laws we're going to look at today are Gay-Lussac's law and combined gas law. And notice we're going to apply them after we discuss what they are. Okay, so Gay-Lussac's law, and you need to look at what is the relationship between the different variables. That's really important. Notice that it's proportional. So it's opposite of Boyle's law, but it's similar to Charles' law, where if you change the pressure, the temperature will change directly because of that. So we have this relationship here, pressure divided by temperature, and notice it's equal to some constant. And if we wanted to look at the before and after changes, if we alter pressure, what happens to temperature? Now, my question to you is, if you have a gas that starts at room temperature, which would be 298 Kelvin, and it is cooled down to 0 Kelvin, what do you think happens to the motion of the gases? And that should affect the pressure for obvious reasons. Okay, so the next law is combined gas law. So notice that we've actually taken the different variables and we've put them in such a way that pressure and volume are on top and temperature is on the bottom. Please remember that the amount of gas has to be kept constant in order for this to work. So here are the 4 different laws that we've talked about at this point, and notice that the way they are arranged, pressure and volume are always in the numerator and temperature is always in the denominator. Okay, so here's a problem here where we have a certain volume of gas at a specific temperature and pressure, and we want to know what is the volume after the changes. So I'm going to take 245 millimeters mercury, and I'm going to multiply it by the volume. And for now, I'm going to keep the volume in milliliters. Notice that centimeters cubed is the same thing as milliliters. And I'm going to divide that by the temperature. Now notice the temperature is 17, which is 290 Kelvin. And that is equal to a pressure at standard temperature and pressure, and that would be 760 millimeters mercury. That is standard pressure, times some volume. We don't know what that volume is. And we're going to divide it by the temperature, which is 0 Celsius or 273 Kelvin. Now, when I rearrange this, I'm going to have V2 on one side, and I'm going to multiply it by 245 millimeters mercury times the volume, which is 34.6 centimeters cubed, times the temperature, which is 273. I cross multiplied, divided by 290 Kelvin, and I cross multiplied the pressure, which is 760. Now notice everything should cancel out. The only thing I should be left with is centimeters. And when I do that, I get 10.5 centimeters cubed. Okay, I want you to do number 2 on your own, and we're going to discuss it in class. Okay, oh, I just threw this in here. If you have Cole's law, notice that you need to have 1 head of shredded cabbage, a cup of mayo, a tablespoon of sugar, a teaspoon of vinegar, and salt and pepper to taste. I prefer a lot of pepper in mine. Okay, so Gay-Lussac's law, please note that we're talking about a direct relationship between pressure and temperature. And lastly, look at gas laws for all 3. If we combine them, notice it's pressure times volume divided by temperature.